Hello there. So today we are reviewing one of the examples from Fast AI book about um, collaborative filtering. We'll be extending this example to cross-selling. So this entire book is actually available free of charge in Python Jupyter Notebook. At this link, I'll provide the link. And the main idea behind collaborative filtering is, let's pretend we have a number of users and number of movies, and they have provided a rating. So 5 is the highest, 1 is the lowest, 0 is the lowest. And we assume that there are some latent factors, product of which results into their observed rating. Therefore, the idea is to find these latent factors using neural network so that the predicted rating and the observed rating is close. This example is provided using publicly available data, which I'll also provide in the code. And the basic idea is that we'll have number of latent factors associated with users, number of latent factors associated with movies, and let's pretend they are the same numbers, and then we are gonna use those so that their sum is close to the observed number. To estimate the neural network for fast AI package, we'll actually have to define our own class module. And then within that, we have to define two functions. One is the init function and another is the forward function. Init defines the structure, like what is how many parameters associated with each of the factors. And then forward function tells you how what data to use for each and what the output is going to be. So in this simpler case, we are actually not including any customer specific features. We'll extend this example to include customer specific features. But just to show that this thing is actually giving you validation loss of around 88%. And then they actually extend it a little bit so that the output that we expect from this function is on the same scale as the predicted ratings. So we're going to extend this. We're going to use the same data as they have used. We're going to also include in our calculations customer specific features like age, gender, occupation, and zip codes. We extract all of that data, we merge all of that data into a data frame called rating. We apply, so now we need to make a tabular object which would go into the training module. So we are going to apply some procs. We are using fill, fill the missing values and also normalize it. Then we are going to randomly split it, and then we're going to tell which data to tabular pandas. We're going to tell what data frame to use, what is the procs which we have defined above, what variables are categorical. In this case, user, movie, and gender are categorical. What variables are continuous? Age is continuous. What is the variable we are targeting? In this case, it's the rating, and split is just split randomly. Then we're gonna assign it to a data loader, and we are gonna use batches of 64. Then we're gonna calculate how many users are there, how many movies are there, and then we're gonna assume 10 latent factors, assign all of this into I guess matrix over here. When we just look into how this looks like, and then we get to our class object that we need to define. So we are naming it collaboration and collab NN, collaborative filtering neural network, and we in the first init we define all the number of parameters that we need. So user have number of parameters, which is number of factors is the number of users, number of item is the number of movies, age is linearly determined, and therefore we apply a linear neural network operation on it. And then gender has two categories, embeddings. So we say assign two categories, and each of them has n latent factor, which is set to 100. Then all these layers are need to go through a linear function first, then ReLU. ReLU is just a 0 1 function. It takes the value of 0 for negative values, and whatever value is positive, that is kept as such. And then we turn all of that into one dimension object, and this is just a sunning range. Forward function specifies what data items to use and how. So user is put into the the very first column. Item is put into the second column, and this we defined over here. User is in the first, item is in the second, and gender is in the third column. And because Python starts from zero, counting from zero, so we have first column, second column, and third column here. And then x continuous is just age in this case. Then we take all of those, uh, put into a layer function, and get ourselves a one dimension object. And we set it to whatever the range we have available with us, y range we have available with us. Then we define a model object, which calls the class object, put it in a learner, specify the MSC loss and data object, and model is just here. It runs, it produces an accuracy of around 90%, and so forth. In this one, we actually add zip code and occupation as well into the collab function. Let me show you how that looks like. So occupation is number of occupations, and then the latent variable zip code is number of zip codes, and the number of latent variables. One thing to keep in mind is, it's okay to have more than plus one categories of the categorical variables. Otherwise, sometimes complain. I'm not sure why, but this is a good practice. Anyways, once we do all of that, we can produce recommendations for the users. And to do that, the function is get grades. This takes all the it requires all the variables we used for the training into a DLS object, and then we write a function to put the ratings for each user, or top 10 ratings for each user which they have not yet seen. So we get a recommendation data set which would have all those ratings. So I'll provide all of these codes in the description or in the comments. Just wanted to take you through a quick example of how collaborative filtering can be used for cross-selling neural network exercise. Thank you so much.